Alright, so we got another problem here. It's number 21. It says find the surface area of y equals 1/2 times the quantity of x squared plus 1 rotated around the y-axis over the integral from 0 to 1 in terms of x. So you got to pay a lot of attention here because the function you're given is in terms of x. The endpoints you're given are in terms of x, but you're asked to rotate it around y. And when you rotate it around y, you want everything to be in terms of y. So we want a surface area function in terms of y, which means we need to get x by itself, and we also need to change our endpoints from x to y. So we've got to take our function, which was y equals 1/2 times the quantity of x squared plus 1, and solve for x. And since we're taking x from 0 to 1, there will be a square root there, but we'll assume it'll be positive. Okay? So when we get x by itself, it'll be x equals the square root of 2y minus 1. And that 2y minus 1 will be our g of y for the function, for the formula. And so we'll take the derivative of that, and then we've got to also square it. So after we take the derivative, we get 1 over the square root of 2y minus 1, and square it, we'll just have 1 over 2y minus 1. So we can take the g of y, which was 2y minus 1 all to the 1/2, plug that into the function, the formula, and plug the g prime squared of 1 over 2y minus 1 into the formula. So that'll give us all the things we need to work with, but we still got to get the endpoints. So my endpoints were given as x being 0 and x being 1. So I'm going to take those and plug them into the formula that was given, the function, 1/2 times x squared plus 1. I'm going to plug those two things in and calculate y. And when I do, the y's will be 1/2 to 1. So a very small height change here. So after everything is plugged in terms of y, the formula will look like 2 pi integrated from 1/2 to 1 as the endpoints times, the integral of 2y minus 1 to the 1/2, and then the square root of 1 plus 1 over 2y minus 1. Again, under that square root, we have a number plus a fraction. So I'll use a common denominator to add those together. That common denominator would be 2y minus 1. So after I do that and pull everything together, under the square root, I'll have 2y in the numerator and 2y minus 1 in the denominator. And since that's a fraction under a square root, I'm going to split it into a square root of a numerator over the square root of a denominator. So that'll give me, in totality here, 2 pi integrated from 1/2 to 1 of 2y minus 1 to the 1/2, and then the numerator of square root of 2, y to the 1/2, over denominator 2y minus 1 to the 1/2 dy. Now, I have a 2y minus 1 square root in the numerator and denominator that I canceled out. So the simpler thing to work with here for the integration is still a square root of 2 up top, and there's a 2 pi out front, so I'm going to pull all that out front. In front it'll be 2 square roots of 2 pi, still integrated from 1/2 to 1 of y to the 1/2. So it's something very simple to integrate. Reverse the power rule. The integral we get is 2 square roots of 2 pi times 2/3 y to the 3/2. Now I haven't cleaned that up yet, but that'll be evaluated from 1/2 to 1. So I'm going to plug the 1 in, I'm going to plug in the 1/2, subtract. An exact answer I get here, possibly in some terms, 4 square roots of 2 minus 2 pi all over 3. But if you put this in the calculator, something that you might understand a little bit better for a number here is 3.829. Alright, that's what I get it when I approximate it. Alright, thank you.